In this lecture, we're going to have a look on file upload vulnerabilities. These are the simplest type of vulnerabilities because they allow us to upload any type of file. So, for example, if the target computer can understand PHP, then we can upload any PHP file or a PHP shell and get full control over the target computer. Now, if the target computer or the target server understands Python or any other language, then you can just upload Python code, Python shell, or Ruby shell. You can create these shells using Vuln evasion or Metasploit, or you can use your own PHP or Python shell. What we're going to do today, we're going to have a look on a tool called Weavly that generates PHP shells and allow us to gain access and do a number of cool things on the target computer. So, first of all, I have my DVWA here. And usually when you're trying to pen test a website, what I recommend is before trying to use any tools or anything, after you do your information gathering, is you just go in and try to browse the website, see what you can see, just get a feel of the website, see what's installed on it and all that, and try to exploit any features you see. So for example, let's say you went on everything and then you reached the upload. We can see that this website allows us to upload a file. Now this sometimes in your penetration testing tasks, it could be a website that's allowing you to upload a profile picture, if it's a classified website, maybe it's allowing you to upload pictures of cars or whatever you're trying to add in the website. So as you can see here, the website expects you to choose an image and upload an image. So let's see if we can upload an image first. So I'm going to go on my downloads and I have a picture here in the resources. Just a picture of a car. I'm going to upload it and see if it gets uploaded. And we can see that the upload was successful and it's stored in this particular location. So it's ... which means 2 directories back and then this file name. So let's see if the picture has actually been uploaded. So I'm taking away 2 directories. I'm taking away the vulnerabilities and upload. I'm only using that. And then we're going to get this location on the server just to see if the picture was uploaded properly. And as we can see, the picture has been uploaded, so that's all good. Now the next thing we want to do, let's try and upload a PHP file. And to do that, we're going to use a tool called Weavly, as I said, to create a payload or a shell, if you want to call it. And it's obviously going to be a PHP shell. You can use Metasploit, as I said, to create a PHP payload. But we're going to be just having a look on a different tool that's designed for web application penetration testing. So the tool is very easy. We're going to put the tool name, which is Weavly, and then we're going to put generate, because we want to generate a payload or a shell file. Then we will put a password for that file so that only us can access it and control the website when we upload it to the website. So my password is going to be 123456. And then I'm going to say where I want to store it, and I want to store it in root, and I'm going to call it shell.php. So very simple. Weavly is the name of the program. Generate is to generate a shell. The password that the shell is going to authenticate us with, and it's going to be stored in root shell.php. I'm going to hit enter, and it's created. Now if I'm already in my root, so if I just do ls, I should see it. And we can see it right here. So the next thing is we're just going to go back to our website and try to upload that shell. And I'm going to look for shell, and here it is. Going to hit on upload. And as you can see now, it's telling me the file has been uploaded successfully and it's in the same place that the picture was. So all we need to do now is we're going to use the same link and we're going to use Weavly again to interact with that shell that we uploaded. Now let's first of all see if the shell exists and it's been uploaded properly. So I'm just going to browse it through my browser. Shell.php. And you can see that you get a blank page, so we're not getting 404, file not found, which means that the file has been uploaded and it's there. So we're going to try to interact with it from Weavly. To connect to it, we're going to type in Weavly. and then we're going to put the URL where the shell is. So this is where our shell has been uploaded. And then we're going to put the password. So my password was 123456. Very simple. Weebly, the URL where the file is, and 123456. This is very simple, similar to when you use your multi-handler waiting for connections or connecting to your backdoor. So we're literally just going to connect to the backdoor that we uploaded. And as you can see, now we're in the file system. So from Weebly, from this place, you can actually just type in any Linux command, and it'll be executed on the target computer, and you'll see the result here. So if I do a pwd, you'll see that I'm in var www hackable uploads. And if I do an ID, I'll see my user at the moment, which is www data. And if you do a uname A, just to confirm that this is the metasploitable machine, you'll see that this is the Linux metasploitable machine. Now we can do anything we want. We can list the files, we can navigate, you can do any Linux command that you want to do. Now we have changed, our place has been changed. Weebly also offers much more features than just this. So it actually allows you to do a number of cool things. If you type in help, you'll see all the cool stuff that you can do with Weebly. So you can try to escalate your privileges, execute SQL queries, and a lot of cool stuff that is just designed for web application penetration testing. For now, I'm going to leave it at this. And this just shows you how to use file upload vulnerabilities. Code execution vulnerabilities. These type of vulnerabilities allow us to execute operating system code on the target server. So if the target server uses Windows, we'll be able to execute Windows commands. If it uses Linux, then we'll be able to use Linux commands. Clearly, this is a really critical problem that would allow us to do anything we want with the target, really. We can upload a PHP shell using a wget command, or upload a payload, a virus, anything we want using the wget Linux command. You just need to make sure that you're uploading it to a file or to a directory which you're allowed to write stuff to. Another way of exploiting this vulnerability is to just run OS commands and get a reverse shell based on these commands. So because we can run operating system commands, we can use the programming languages supported by that operating system to try and get a reverse connection on our computer. So first of all, let's just assume that we're browsing here and we're going around, and then we got to a tab in the website where it allows you to, for example, do a ping. Now, what you should do is you should always try to experiment with any input box you see. Try to see what that input box does and what can you inject into it. What can you do to get stuff running? So, for example, this input box is telling you it's going to do a ping. And if you put an IP, for example, I'm going to put 10.20.14.203, which is my own IP, just to use it as a normal person. And I'm going to do a submit, and it's going to go ahead and ping it for me and give me the ping results. So what looks like here, it's actually executing the ping command in Linux systems. Now, let's see if we can exploit that. If it's actually executing the ping command. So what it's doing is it's going and it's doing, so we're sending 10.20.14.203 as the ping, and then it's going to the web server, and the web server is doing ping 10.20.14.203. So let's see if we can exploit this. How would we exploit it if it's taking what we're inputting right here, and then it's doing ping that? Now, in Linux and Unix-based commands, you can use this sign to execute multiple commands on one line. So if you do this, if, for example, in your own terminal, so I'm just going to go to my terminal here, and I'm just going to do ls, which is the list command, and then pwd is what shows your working directory. So if I do an ls followed by this sign and then do pwd, it'll execute both commands. So it'll do this, and then it'll show where the working directory is. So we can do the same thing with this and see if it works for us. So we're going to put an IP, a right IP, And then I'm just going to do pwd and see if it'll execute the pwd for me. If it does, then this is a code execution vulnerability and I can execute anything I want on the server. So let's see what's going to happen. I pasted this and I'm going to hit submit. And as we can see, we got the ping results. But at the end, we got our current working directory. So it's var www dvwa vulnerabilities and exec. So it executed the pwd that I inserted. And that means I can insert any commands I want in there and they'll be executed. So I've inserted a resources file that you can use to get reverse connection from the target computer. Now there's a number of ways, a number of commands that would give you a reverse connection. All of these commands depend on the programming language. So for example, we have commands in PHP, we have commands in Ruby, you have Perl commands, and we have the one for Bash. Bash is the Linux shell command language. So all Unix operating systems will be able to execute Bash commands. So that's a very good way of doing it. So most Unix system, this command should work on most Unix-based systems. So this would be a really good way of doing it. Again, most of them would have Python, so Python would be a good way. Netcat, most of them do have Netcat as well, so Netcat is a good way of doing that. And we're actually going to use Netcat in this video. So what I'm going to do is first I'm going to listen for connections, just like we used to do with Metasploit when we used to do multi-handler. You can actually use a multi-handler for this and listen for connections, but I'm just going to keep it simpler and show you a new way. And I'm going to use Netcat. So Netcat is just a tool that allows you to listen and connect computers together. So I'm going to listen on port 8080. So Netcat is the program. VV is just to see verbose output. So we can see a lot of output. Anything goes wrong, we can see it. And we're telling it to listen using the L option on port 8080. So I'm going to hit enter. And that's saying it's just listening on port 8080. That's all it's going to do. The next command we're going to do is we're going to try to connect from the web server back to my computer using Netcat as well. So we're assuming the web server has Netcat. We're going to try it and see if that works. So the command is very simple. It's Netcat, and we're telling it to use the bin bash. And we're giving it the IP of my device, my attacker device, which is 10.20.14. And then the port, which is 8080, which is we're listening on right here. So I'm going to copy that. And I'm just going to execute it the same way we used to execute the pwd command. So the last thing we did was 10.20.14.203. And then we did pwd. So what I'm going to do now, I'm going to remove the pwd and paste the code that we just created, which will try to connect from the web server back to the Kali machine to the attacker machine. And I'm going to come here. And as you can see, we got a connection back from to us from 10.20.14.204. So that's the target computer. And if we do a pwd, you'll see that we have a reverse shell. If we do an ls, if we do an id, you'll see that we're www data. And if we do a uname a, just to confirm that I'm in the Metasploitable, and you can see that I'm in the Metasploitable, and I'm able to run any command that I want on the target computer. So basically, I have full access to the target computer. Local file inclusion vulnerabilities. These exploits or vulnerabilities allow you to read any file that is within the same server. So even if the file exists outside the var www, you'll be able to read it and read info with it. Now, why this vulnerability is critical, because you can read any files. So if the users are storing some sort of important files or password files, then you'll be able to read them. And then from there, you can further exploit your target. Also, if there is a number of websites on the same server, and you manage to find this on a website that you're not targeting, then you might be able to access files related to the website that you're targeting and then further exploit your website from there. So let's have a look on this. And we'll also, the way we're going to be exploiting this vulnerability is through the URL. So usually in our code execution example, we were writing the code in here. Now, sometimes you might find the code vulnerability in the URL. So it will be something like cmd, and then you put the command, or for example, in this case, it would be IP equals to the IP, for example, 10.20.14.203, and then you put the sign, and then you put your PWD after it, for example. So, because our example was just in the text box. Same is going to happen here in our file inclusion vulnerability. So we can see that when you're in here in this URL, it's saying that this file is going to take a page and it's loading something called include.php. So it looks like it's actually loading another page, like this current page is loading another page called include.php. So again, you'd be browsing the web server and trying to get a feel of it, and you see something like this, or you see something called IP equals the IP, and then you know that there's a ping, for example, for the previous video. So for this, that we know that our target is trying to open a file, and the file is called include.php. Let's see if there is actually a file called include.php. So I'm just going to remove everything here and try to access include.php directly. And as we can see, we actually do have a file called include.php. It's not running properly, but it exists and it's in the same working directory. So let's try and see if we can read a file that is stored in the computer. And we're going to use a file called etc password. So that's the file which contains all the users and their paths on the current web server. So let's have a look on this. So etc, this file contains all the users for the current operating system. So if I just go on my Kali right here, and if I run it here, if I just do cat etc password, you'll see all the users that I have on the current computer and their default path on the current operating system. So we're going to try to read this file. And to do that, let's go back and see our current location. So our current location is in the FI file, in the FI directory. So we need to go back 1, 2, 3, 4, 5 times, and then go to etc password. So going back would be done using the ... And let's try and do that. So at the moment, we're accessing this current file. And just to make it easier for you, actually, let's just put the full path right here. So on the page, it's trying to access this page. So what we need, we actually want a place called etc password. So we need to go back 5 times for these directories. So this one is going to be, let's start them from here. So we're going back, 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 and back. And then we're going to go to etc password. And as you can see, now we have the output of the etc password file. We can copy that and store it here. And then you'll be able to read it and just get more information about the websites that you're targeting right now. Again, you can use this to try to access different files, sensitive files, or files of other websites on the same server. Remote file inclusion is a special case of file inclusion vulnerabilities. We've seen in the previous video how we were able to include any file in the server and have access to it through local file inclusion vulnerabilities. In today's video, if the server is configured to allow a certain function called allow URL and allow URL fopen, then we will be able to include any file from any computer into the target website. So we'll literally be able to inject any PHP file into the target computer. What this would lead to is basically we can run payloads, we can run reverse shells, and we can run even system commands and get access to the target or full control to the target server. So first of all, let's just go here, and we'll be using the same file inclusion vulnerability that we were using in the previous video. So it's in the page parameter right here. The only difference is you need to enable the function that converts the local file inclusion to a remote file inclusion. So hence the name local allows you to access local files. Remote will allow you to access and inject remote files. So to enable that, I'm going to go to my Metasploitable machine. I'm just going to show you how to enable it so you can test this vulnerability yourself. So we're coming here to our Metasploitable, and I'm going to go into the PHP settings. So the PHP settings are stored in a file. And to access that, we're going to use Nano, which is a text editor. And then I'm going to put the file location, which is in etc php5 cgi and php.ini. So that's the location where the PHP configuration is stored. I'm going to open it using a file editor called Nano. And I'm just going to exit this. I'm going to open it as sudo as the root. Actually, in Kali, we never needed to use sudo because we log in as root. But with Metasploitable, you need to use sudo when you want to do root actions. So you say sudo, and then you put the command that you want to run. Okay, so these are the configurations for the PHP that's installed on the web server on the target. And we're looking for a function called allow URL fopen. So I'm going to type in Control and W at the same time, and that'll allow me to search. And I'm going to search for allow URL. And we can see here that I have allow URL fopen is on, and allow URL include is on as well. So these two functions, if they're enabled, then the local file inclusion vulnerability that we have can be used as a remote file inclusion. So to exit this, Control and X, and it's going to ask you if you want to save, just type in Y and enter. For me, I didn't change anything, so I didn't need to do that. Once you do that, you need to restart your web server. So you're going to do etc init.d apache2 restart. And you'll need to do this as sudo actually. And this is done now, so everything should be ready for you. Just like we did before, in the last video, we put 5 times back and then we put etc password to access the password file. What we're going to do today is we're going to try to access a file located on a different server. So if you're doing this pen test on an actual web server, then you need to store the file that you want to access needs to be stored on a place with a real IP address or with a domain name. I'm doing this on my local server, so I'm going to store this on the web server on the Kali machine on the 10.20.14.203. This is 10.20.14.204, and I'm going to store my file on 10.20.14.203. So that file, as I said, can be anything. It could be a web shell, it could be a payload. Well, what I'm going to do is I'm going to create a very simple PHP file. So this is just the PHP start and end of the file. And what I'm going to put in the file, I'm going to use a function called passthrough. And in that function, basically what this function does, it executes operating system commands. So it executes Windows, Linux, or depending on the web server, it's going to execute commands related to that. So you put the command here between the two quotation marks, and I'm going to use the same command we used with the code execution vulnerability, which was the netcat command, which allowed us to get a connection, a reverse connection from our target. So I'm going to paste that here. So let's just first have a look on this. So PHP and the end, these are just the start and the end of the file, of the PHP file. Pass-through is a function that I'm going to use which executes any command that's inserted between the quotations. And I'm using the same command that we used in the command execution vulnerability, which will just do a reverse connection to my computer. So this is all good. Now the next step is the most important step, and it's storing this file. So as I said, if your target was a remote web server, then you should be storing this file in a place with a real IP where you can access it from the remote web server. Now I'm going to be trying to access this from my Metasploitable machine, which is able to access files stored on the Kali machine because they're both on the same network. And I'm going to be calling this, I'm going to be storing it in my var www.html. So it's being stored on the Kali, not on the Metasploitable. And I'm going to call it reverse, and I'm going to save it as txt, not PHP. And I'm doing this, if I store it as a PHP, it's going to be executed on the Kali machine. So it's going to create a reverse connection from the Kali machine. And I don't want that. I don't want to hack the Kali machine. I actually already have access to the Kali machine. The one that I want to hack is the Metasploitable machine. And that one is stored remotely. So in order to be able to include a PHP code and execute it on the remote machine, we're going to use it as txt and get it executed on the Metasploitable machine instead of executing it on my Kali. So I'm starting it as a txt, and I'm going to save it. And now let's just see here. So if I go to my local host, and if I say reverse.txt, we'll see our file right here. So again, this is on my local host, which is not the Metasploitable machine. It's 10.20.14.203, and the Metasploitable is on 204. So how are we going to run this? First, let me just listen for connections like we did before. So it's just going to be netcat vvlp 8080. And then right here, instead of including a file on the same server, I'm going to include a remote file, and the command is going to be http. So it's just going to be the link to this file. So we can access the file here as txt. I'm going to copy it and paste it here. And also in some cases, you might need to add a question mark to the end to get this file to be executed as PHP. So I'm just going to go over this again for one more time. Including a remote file, which is on a remote server. Make sure the remote server is accessible by your target. And also make sure you store it as txt, because if you keep it as PHP, this file, the reverse file, will be executed on the remote server. So it will be executed on the 203 instead of being executed on the 204. And I'm keeping it as txt. This way it's going to be executed on the 204, and it's going to give me a remote connection to this computer, to the Metasploitable computer. So if I come back here, as you can see, we have a remote connection. If we do a uname a, you'll see that this is the Metasploitable machine, not the Kali machine. So we basically have full access to the Metasploitable machine through a remote file inclusion vulnerability. Now, if we do an ls, we can do a pwd to see where we are, and we can literally run any Linux command we want now on the machine and do anything we want. Basically, we have full access to that machine. Let's talk about how we can prevent these vulnerabilities now. The first thing is, a lot of these vulnerabilities exist because of the functionality they provide. For example, the file upload problem we had, it allows the user to upload any file extension, any file type. This shouldn't happen. There shouldn't be a way for users to upload any files they want. Maybe if you want them to upload a picture, then make sure they're uploading a picture. Check the file types. If you're expecting them to upload a song, an MP3 file, make sure it's a media file. It's not a PHP or an executable code. Usually, you should never allow users to upload any executables. Filters can be used to check the extension and make sure that the file is being uploaded that is a JPEG or whatever, but that's not a good way. The best way is to check the file type and make sure the file type is a picture or is a media file instead of checking the extension, because that can be bypassed as well. The second type of vulnerabilities that we looked at was the code execution vulnerabilities. In these exploits, we were able to run any code we wanted on the target computer. Again, this functionality should be avoided. You should avoid allowing users to run any sort of code on your server. Try to avoid all these functions such as the eval, pass-through, and all these functions that allow a user to run operating system code on the server. If you absolutely had to use something like it, then make sure you analyze the input before you execute it. For example, in the example we seen, where the code was doing a ping, and it'll ping anything we put in the text box. So I'm putting here a / text box just to show that this is the input that we put in the text box. This is what the program actually looks like. If it looks complicated, forget about it. We're just talking about the concept here. So we're going to be talking about this here. So say, for example, what we did is we put a normal IP, and then we put the semicolon, and then we put a command that we wanted to do. So we did, for example, lsla. The problem with this is the web application used to take this the way it is, copy it, and run it in here, which will, when you execute this command, it will do the ping first, and then it'll do the lsla, which is the command that we wanted. What you need to do is, for example, if you had to do it, what I advise is you just don't use these functions. If you had to use a function like this, then what you should do is check that the input is what you're expecting. For example, you're expecting an IP address and nothing else. So you can use regex to make sure. Now, I'm not going to talk about regex or what regex is. Regex is basically a rule that will make sure that the input looks on the following format. So it takes a digit, dot, digit, dot, digit, which if I put anything else, then the web application should refuse it. You can also make sure that there is no semicolons and that there is no spaces. So everything comes in as one thing and then it gets executed. Again, this is a way of making it more secure, but the best thing is just to avoid these functions. The third type of vulnerability that we looked at was the file inclusion, and we looked at two types. The local file inclusion, which allowed us to include any file on the system and then read files, which will cause a file disclosure vulnerability, and then you'd be able to read any file on the server. And then we looked at the remote file inclusion, which is very dangerous, which allowed us to include any file from any web server. So we were able to include PHP shells and then get connection from the target computer. To prevent these, first of all, make sure you prevent the remote file inclusion. So just in case anything goes wrong, people can't include files from outside your server. And you can do that the same way we enabled it using the PHP INI by disabling the allow URL of open and allow URL include. And if we go here to our Metasploitable, I'll just show you very quick. So if we do sudo nano, which is the text editor, etc php cgi php.ini, the same file that we used. This is the file for the PHP settings. If you open that file, and now I'm going to do Control W and look for allow URL. And you want to make sure that the allow URL of open is set to off, and allow URL include is set to off as well. Control X, Y, and enter, and that'll save it for you. The other way to prevent these exploits is to use static file inclusion. So instead of using dynamic file inclusion, which we've seen, you can hard code the files that you want to include in the code and not get them using get or post. For example, what's happening in the examples we see in the vulnerable examples is we have a page called page or index.php. And then this index.php takes a parameter called page, and then it takes another page, for example, news.php. And it includes this news.php in the code. So what's the code look like? In the PHP code, you'll see something like include So what this will do basically, and that looks like this, I believe. What this do, it includes whatever comes after the page parameter. So the code will dynamically takes whatever that comes in after the page parameter and includes it in the current page. So this will be in the index.php page. Okay, this is very bad because even if it's not get, sometimes people use post, and in post you won't see this, so it will be posted. But you can use a proxy such as burp proxy, and this would look like that. And then you can modify it and get it to include anything you want, and then it's displayed on the page. What we really want to do is we want the user not to be able to manipulate with what's going to be included. So if you wanted to include a page called news.php, just include it inside this without giving the user the ability to change it. I know you're going to program your code to just have it looking like this, but the users, we've seen how users can play with this and just get it to include anything they want. So the best way to do it is just to get it to include page.php. So your code is not using any variables. It's hard coded. It might make your code longer, but it's much more secure.